to do is simplify this. We cancel these two terms. And we're left with 1 over x plus 3. Now before we go on, because we don't want to make silly mistakes on our test on Friday, we cancel this and we write a note to ourselves, giving whole at x equals 2. Alright. Now we're going to draw this graph. As usual, but when we get to x equals 2, we make sure we remove that point. So what should this graph look like? 1 over x plus 3. Where do we have a vertical asymptote?
Negative 3.
X equals negative 3. And is there a value that y cannot reach?
No.
No.
It's our usual culprit. Can we get to 0 from here?
Yeah.
What value of x can we plug in?
Negative 3.
No. Oh, no.
For x?
We get undefined.
Oh,
This
that's
is
undefined.
where all of this can equal 0.
Yeah.
Y can equal 0.
You can't.
There is none. So, just like our parent function for our reciprocal, y equals 1 over x, we have the horizontal asymptote at y equals 0. We can calculate exactly which point this hole should be at. So when x equals 2, we know that there should be a hole. So if we plug in 2 here for x, we get 1/5. So that means that our hole will be at 2 1/5. Not necessary, but it does kind of help us see what the entire graph should look like. We could just graph this and pull up that point. We can also find exactly what the point is by plugging in x equals 2 after we've canceled these two terms. Just like any other point on this graph. We plug in an x, and we see what we get out for our y, and we can plot that coordinate. Yes?
I have an unrelated question.
Is this a good time to ask it?
It's interesting. Does calculus study the area under the curve?
Yes.
Oh my god, that sounds horrible.
No, it's really cool actually. Starting that today. We're going to calculus class.
What?
Questions about this process? How holes show up in graphs, how we graph after we've canceled. Does this make sense? Yeah?
I'm confused. Why is there a hole and not another avenue? You know what I mean?
Mm-hmm.
Is there any?
Yes. Let me give you another example that will make it clearer why this should happen. So let's say that we have y equals x plus 2, x plus 1 over x minus 3, all over x squared minus x minus 6. Chat with each other for a minute. See what we can do to simplify this function. Let me know what you come up with.
X plus 3 and x plus 1.
X minus 3.
Alright, looks like we're all on top of it. So what's happening? What are we going to do first? Factor. We want to factor the bottom. Ideally, we have terms that cancel out, right? Gives us a simpler equation to work with. So we can rewrite this. X plus 2, x plus 1, x minus 3, all over. This factors the x plus 2 times the x minus 3. So these terms will cancel out. And again, before we move on, what does this mean? At x equals -2 and 3. And what are we left with?
X plus 1.
Y equals x plus 1. Now what should this look like? Linear equation with a line. So we start up at 1. We can also find the points where we would have holes by plugging in these values to our simplified equation. So at x equals -2, y would equal -1. So we'll have a hole at -2, -1. At x equals 3, y equals 4. So we'll also have a hole at 3, 4. Right? This is where those points would have been on our line. We just don't.
Can you go
Keep
back up for a
those.
second?
Can I go up
Yeah, like to where the asymptote is.
here? From the problem before?
So that one's an asymptote because like it's never gonna reach that value. Is that
Which one is an asymptote?
the x equals -3?
X equals, because, yeah, we can't reach.
So when something's undefined, it's an asymptote. Like that line would be an asymptote.
Yes.
Okay. And y equals 0 is also an asymptote
Because
because
we'll never be able to reach the height of 0, given this function.
okay.
We can also use our knowledge of the parent function, right? We know generally it should take this shape. There will be those two asymptotes. Normally it would be at x equals 0, y equals 0, but this tells us this is just a translation left 3, right? We've affected our x's, our inputs to the left 3, so everything should just shift
So
left 3.
for an asymptote, you'll get an equation of a line, and then for a hole, it's more so like a specific point. If that makes sense.
Yes, so asymptotes give equations of line, y equals a value, x equals a value.
Okay.
For a hole, it is that point that we remove from the graph.
So there, when you cancel that, like, or you know how there's like an x plus or x minus 2 and x minus 2. So and then when you cancel those out, that's when there's a hole. But if there's like x plus 3 is still there as the denominator, then that's the
Because, at every other value of x, so let's say we just plugged in x equals 1, then we get -1 and -1. And those values will just cancel each other out. So this is fine for any other value of x. It's just when x equals 2 that we can't plug in that value because it's our original function. 0 over 0 won't cancel out the same way that 4 over 4 cancels to give us 1. Anytime we get 0 in the denominator of our original function, right, we can't have x there. So if it would normally just cancel out with another term in the numerator, we only remove that point. So here, I think it should be really clear that we shouldn't have an asymptote for something like this. When we cancel these, we just get holes, and we graph the function that we're left with after we've canceled those common terms in the numerator and denominator. All right. Are we good on this? Yes? Can I get thumbs? Can I check in with everybody? Okay. Most of us are good. Other questions? Is there something that I can give you an equation for that you would like more work with? Okay. Then I would like you to work with your groups. So write an equation with a vertical asymptote at x equals -7, a hole at x equals 3, and a horizontal asymptote at y equals 0. So there are many different possibilities for this. Come up with one that fits. All three of these are quite good. You're done.
The hole at 2.